Okay, good morning, everyone. Uh, so today we talk about the results of the heat transfer from the cores to the mantles. Okay, and it generates the Earth magnetic field. For this one is the inner core. Okay, where it is the source of the heat inside the Earth, and this area it is areas of the mantle, where we have the molten rock. So the heat here will transfer from this area here up to the lithosphere, okay, and it moves down this way, okay. So we have the movement of the positive charge, okay, from one area to another area here. So this one here, they will make the Earth here look like a magnet, where we have a lot of the positive charge in some specific area. For example, this one here, we have a lot of the sodium. Sorry, we have a lot of the iron and nickels distribute. And another position here, we will have the negative charge. Okay, but the negative charge here is not real negative charge. It is area that we have smaller amounts of the positive charge. So this one here will represent as a negative pole. Okay, so this one here we can draw the line from the positive pole to a negative pole this way. So it generates the Earth magnetic field. And the magnetic field is very important to protect us from the UV ray and the cosmic ray. That is very dangerous to the living things on Earth. Okay. And if we compare the densities of the Earth layer here from the crust will have lowest density and get floating above the mantle, whereas the density get increased about 3.4 to 5.6. And here down deep to the outer core, we have 9.9 to 12.2, and goes to the inner core, that is 12.8 to 13.1. Okay, so this will be each layer here. If we compare the layers of the Earth here, from the outermost layer to the mantle, to the outer core, and to the inner core like this, the density here will get increased. This way. Okay, and we can study the lithosphere and asthenosphere by using seismic wave. The seismic wave here contain P wave and S wave. Okay, the lithosphere and the for the first 100 kilometers, it is a solid layer. Okay, this one. Okay, so the wave here can be transferred very fast from the first layer. So this one so-called lithosphere. But when it passed into the next 100 to 35 kilometers, it turned into the liquid light, solid, the softened rock. So it reduced the speed of the wave transfer. So we can call this area as the asthenosphere. And here, so when you understand what is inside the Earth, so now here we will understand it can explain the effects and the results of changings on the Earth surface. So it produced very different landform. So the landform is a change of the crust layer caused by the geological event. So we will have very different landform as island, continental shift, okay, or even cape, or even the area near the sea we call the coastline, or the small mountain we call hill, okay, or the canyon, the area that get eroded by the water, and the cliff between two mountains we call valley, and the very big hill, the mountain, big mountain. Okay, so the geological change on the surface here can occur in three ways as the weathering, the erosion, and deposition. And today we'll talk about the first part here, weathering. Okay, the weathering here is a process that breaks down the rock into the smaller pieces by many factors. For example, the water, the wind, wave, and even sunlight, so-called the weathering factors. Okay, and the weathering factor here affect in a different area differently. Okay, so it's the aim of the weathering process here is to break down the large pieces of the rock here into the smaller one. But this one here is not related to the process of movement of the smaller piece of the rock here from one place to another place. So if you mention about the movement of the particle from one area to another area, it will be about the erosion process. And we can separate the weathering process here into two processes, so-called the mechanical weathering and physical weathering, or physical weathering, and another one is chemical weathering. Okay, so today we will focus on the mechanical weathering first. The mechanical weathering here represents the process that the rock breaks down into the smaller pieces and without changing of its composition. For example, here if the rock contains the calcium carbonate, it will break into the smaller pieces of the calcium carbonate without any changing of the chemical composition inside the rock. Okay, so this one here I will give you 4 examples. As the plant and the root here split the rock into 2 pieces, and even the water freezes the split the rock into the smaller piece. We call ice bridging. Okay, and the solution here dissolves the mineral that is compositions of the rock and get evaporate and grow up the size of the crystal and break down the rock. Okay, we call dissolution. And the expansion and contraction. This one here caused by the changes of the heat during the day and the night time. Okay, in a very cold and very nice area. Okay, the first one is mechanical weathering by ice bridging. So this one here occur into very high land where we have the snow. Okay, the snow here. Okay, when we have a snowflake get into the cliff of the rock like this during the winter time. Okay, and after that here, when it turns to the summer, here the snow will turn to the water. Okay, so the water here gets deep and go down deep into the crack, and it turns into the second winter here. The water here will turn into the ice. When the water turns into the ice here, the volumes of the water will increase, and it enlarge the size of the crack. So that way here the crack will be go down deep into the rock and makes the rock here become break down and falls and break into the smaller piece. Okay, so this one here will be the first mechanical weathering by the ice bridging. The next one is mechanical weathering by the plant roots. So this one occurs in the tropical rainforest. Tropical rainforest where we have the rainfalls. Okay. For example, here we have the root of the plant, the plant seed here above the rock like this, and we have the small cliff, and we have the rainfall. So the seed here will get germinate inside the rock this way. So the seed here will grow up into the crack, okay, and it excretes the acid to corrode the surface of the rock. And after the root will get into the crack like this, and when the root get enlarged, it will give the pressure to the rock. So the rock will break down into many pieces like this. The dissolution of minerals. So this way here in the rock here composed of many different types of the minerals. The first one here is water soluble mineral, and sometimes it can be water insoluble minerals. Oh, sorry, this one is insoluble mineral, and this one is water soluble mineral. For example, the halite. The halite contains sodium chloride that is possible to dissolve into the water. So this way here, when the water in the soil here get flow or pass through this type of the rock or even the rainfall like this, the sodium chloride in the halite here, will be dissolved through the water. Okay, dissolved through the water. So this way here, you will lose the masses of the rock. Okay, so when the animals and even the human here pass to this area, so they will have the force acting on the rock. So the rock here will get break into the small pieces this way. So this solution of the mineral. So this one may be occur very near to the river or the stream. Okay, and expansion contraction occur in the desert. So this one here we have a larger pieces of the rock. So during the daytime, it's very hot, so the rock will get enlarged. And after that, during the nighttime here, the temperature get lower, so the rock will get contract, a little bit smaller. And when the rock get enlarged and get shrink, enlarge, and shrink, enlarge, and shrink like this. The surface of rock can get break down into the smaller piece like this. Okay, so they get cracked. Okay, thank you very much.